Welcome to This Explainer. Look, if you're completely exhausted from untangling, messy, unmaintainable spaghetti code, well, you are absolutely in the right place today. We're going to take all that dense architectural theory and transform it into a highly practical, step-by-step tutorial. We're talking about taking you from chaotic code all the way to a rock-solid, layered architecture. Let's get into it. Okay, let's dive into our roadmap for today. First up, we'll cover the design process foundation. Then we'll jump into the 9-step layering masterclass, followed by some very specific layer guidelines. And finally, we'll wrap up with evaluating your architecture. All right, part 1, the design process foundation. Before you write a single line of code, you need this 5-step iterative process. First up, identify your objectives. You've got to document exactly what problem it is you're trying to solve. Number 2, define your key user scenarios. Third, get your application overview together by choosing your tech stack. Fourth, pinpoint those key issues where design mistakes almost always tend to happen. And finally, number 5, develop your candidate solutions. You'll literally just iterate through these steps until your blueprint is absolutely solid. Now, to effectively tackle that 5th step, I highly recommend a technique called an architectural spike. Sounds intense, right? Basically, it's just a test implementation of a really small, specific part of your overall design. Don't try to build the whole system right out of the gate. Instead, just test a thin slice early on. Doing this validates your technical assumptions and, trust me, it prevents massive headaches down the road. So you've got your objectives locked in, your assumptions are tested, and you're feeling good. But how do you actually take all these crazy moving parts and organize them into a neat, logical, layered structure?
Well, that brings us to part 2, the 9-step layering masterclass.
Let's walk right through the first 5 steps of this masterclass. Step 1, choose your strategy. Basically, how granular does your architecture really need to be? Step 2, determine the layers you'll actually require. So, think presentation, business, data, and services. Step 3, figure out how you're going to physically distribute those layers across your servers or tiers. Step 4, decide if you need to collapse any of those layers for, say, simpler applications. And Step 5, determine your interaction rules. Listen, do not skip this one. Deciding exactly how these layers are allowed to talk to each other is literally the thing that will keep your system from totally collapsing under its own weight later on. Speaking of Step 5, you're usually choosing between top-down and strict interaction. Top-down interaction lets higher-level layers just bypass the middle ones. It's great for speed, sure, but bad for tangled dependencies. On the flip side, strict interaction literally forces each layer to only talk to the one immediately below it. Think about it. If you update a database table, strict interaction ensures only your data layer breaks, not your entire user interface. Pretty crucial, right? Moving right along, Step 6 introduces cross-cutting concerns. These are features like authentication, caching, and logging, stuff that spans across all your beautifully neat layers. As the architect, you have to build centralized, dedicated modules for these things. Because if you don't, you're going to end up copy-pasting and duplicating code absolutely everywhere, which is a total nightmare. So once you've identified those cross-cutting concerns, Step 7 is defining the actual interfaces between your layers. You really want to enforce loosely coupled interfaces here so your layers never accidentally expose their messy internal details to one another. Then, Step 8 is choosing a deployment strategy that fits your security and physical constraints. And finally, Step 9, choose your communication protocols. Honestly, if you nail these 9 steps, you are looking at a world-class architectural foundation. Okay, so we've got our overarching strategy and a really solid structural blueprint in place. But let's roll up our sleeves and get our hands dirty for a second. What actually goes into each of these architectural layers when you're looking at it on a practical component level? Let's find out in part 3, layer-specific guidelines. Starting at the very top of the stack, we have the presentation layer. Your absolute primary directive here, strict separation. You must separate your UI rendering from your underlying application logic. Also, you really should consider caching data directly in this layer just to maximize that UI responsiveness. And please, design a centralized exception management system that catches errors gracefully. Just make absolutely sure it never, ever exposes sensitive system or database info to the end user. That is a huge security risk. Now, right before we dive into the business layer, I need you to remember this golden rule. Deploy your business entities on the exact same physical tier as the code that actually uses them. Seriously, strictly following this rule is absolutely the best way to maximize your performance and just kill completely unnecessary network lag. All right, now for the business layer itself. This is the true beating heart of your system. It contains your application facade and your pure business logic. which further breaks down into workflow and entity components. The key takeaway here is you must completely isolate your business rules from your UI and your database. Keep this layer strictly focused on the business process and nothing else. Moving down into the data layer, you're going to face a classic architectural debate: stored procedures versus dynamic SQL. Now, interestingly enough, in modern database engines, both of these actually offer very similar performance. So what does that mean for you? It means your choice should primarily be dictated by how your team prefers to manage and maintain SQL code, rather than just worrying about raw execution speed. Wrapping up our layer specifics, let's look at the data and service layers. For the data layer, you must completely encapsulate all your data access logic and absolutely centralize your database connection management. When you're exposing functionality via a service layer, design those services to be application scoped. Oh, and remember the ultimate golden rule of services: never ever trust an inbound message. Always validate and sanitize your inputs to protect the architecture you just worked so hard to build. Which brings us to our final section, Part 4, Evaluating Your Architecture. To evaluate things effectively, we use a fantastic methodology called ATAM. That stands for the Architecture Trade-off Analysis Method. Essentially, it's a proven, highly structured review process used to discover technical risks and evaluate your decisions against critical quality attributes. Think security, think scalability. Honestly, it's a super cost-effective way to find massive, glaring problems early on. You should definitely be implementing this before any costly coding actually begins. Now, a full, formal ATAM process, that can literally take weeks. But here is a lightweight ATAM addenda for you. You can take this practical evaluation and run it with your team on Monday morning in just about 0 to 3 hours. Here's how it works. You present the business drivers, you present the architecture, you generate a utility tree to map out your vital scenarios, and then you just analyze your approaches. It's a brilliant way to get all your stakeholders completely aligned on exactly where the architectural weak points might be hidden. And that brings us to the ultimate checkpoint of your entire design process. As you go off and architect your next application, I want you to ask yourself this one critical question. Does your candidate architecture actually succeed without introducing any brand new risks? Are you genuinely solving the core business problem? Or at the end of the day, are you just trading one set of architectural risks for another? Something to think about. Thanks for joining us for this explainer, and we'll catch you next time.